Hello everyone. First, a little test. Can you hear me right now? Okay, well, hello everyone. Today we will be watching the launch of the NROL-77 satellite with a SpaceX Falcon-9 rocket. Uh, I'll try to add some commentary, although there's not really that much known since it's a somewhat classified mission. It's a reconnaissance satellite from the National Reconnaissance Office. So not really much is known about the payload. We do know that the Falcon rocket will not attempt landing on a drone ship, but instead actually fly back to the launch zone and land on a landing pad, which makes sense since the target orbit needs less fuel than many other satellites. It is most likely that the target orbit is pretty close to a what's known as a Molniya orbit, which is a highly eccentric orbit. It has a an orbital period of 12 hours roughly, so it's not a geostationary orbit, but it has some similar properties. It's highly eccentric, and at the apogee, it has a similar radial velocity to a geostationary orbit. So during that apogee, you have several hours where the satellite is almost stationary over a certain location, and then it comes down to perigee at rather high velocity, and then it comes down up to apogee again, and again stays almost stationary above the location, although now 180 degrees on the other side of Earth, since it's a 12-hour period and Earth has rotated beneath it. This orbit is often used for both telecommunication and reconnaissance satellites for high inclination targets, so either very far to the north or very far to the south. This one will probably launch on a more northern trajectory, so that the apogee is above the northern hemisphere and the perigee is above the southern hemisphere. While we do have a rough idea of what kind of target orbit this mission will reach for, the anything about the actual satellite's design is simply classified. However, it seems that the live coverage will go on, just not showing the satellite, other than with earlier annual launches, where often the launch coverage would be rather abruptly ended after fairing separation. In this case, they just don't show the satellite's actual shape in the animation, and obviously won't be publicly showing the satellite facing cameras. Uh, they'll also be showing the boost back and landing, which will of course take a little longer than with a drone ship landing, and is actually pretty much the latest activity will be the touchdown of the first stage. Uh, it's technically a little difficult to get much louder. I'm still trying out different ways that could help, but right now, unfortunately, the only way to get it much louder is essentially to turn up the volume, and if that's at the top limit, then there's not really much I can do right now. Here we have some basic schematic representations of what a Mjolnir orbit roughly looks like in orbital trajectory and ground track. Uh, I'll just show this to you for a short time now. The official launch stream is pretty soon to begin. I must apologize, I am a little bit tired right now because yesterday was, oh, of course, depending on time zone, but yesterday was the anniversary of Yuri Gagarin's flight in orbit, and there was a bit of a small event going on, and so it was a. So I'm a little bit tired right now, but I'll still try to comment and cover this launch stream. Yes, this is the reusable Falcon-9 rocket. It will not land on a drone ship, but it will land back on Cape Canaveral, as today's target orbit does not require as much fuel as other common target orbits. The Falcon 9 can pretty much just spare that little bit of fuel to turn back and land back at the Cape, which is of course much easier than landing on a drone ship. Yes, the live stream will cover the landing of the rocket, but the coverage of the second stage reaching orbit will be it's not exactly clear, but it will probably be cut off since the payload itself and its exact trajectory is classified. The Falcon-9 for this launch will head towards northeast, probably something of a 40-degree angle roughly, so a high inclination orbit. The payload is targeted for while the exact trajectory is classified, it will roughly be a Molnier orbit, that is a highly eccentric orbit with a semi-major axis and an orbital period less than that of a geostationary orbit. Actually, the orbital period will be half that of a geostationary orbit, but the perigee is basically around the altitude of low Earth orbit, and the apogee is just slightly below that of a geostationary orbit, so that during that apogee the satellite is almost stationary over a certain location for a short time, that is for a few hours. Now, while we're pretty much still waiting for the actual live stream to begin with the intro still running, I've taken the other fallaway preparation stream. Okay, it's beginning now, so that's pretty much pointless now.
You're looking at a live view of the Falcon-9 rocket on the SpaceX launch pad, preparing for liftoff in just about 10 minutes from now at 7:15 a.m. Eastern Time. Hello and welcome to the live webcast of the NROL-76 mission. I'm John Federspiel, a lead mechanical design engineer here at SpaceX, and today SpaceX is launching a classified payload for the National Reconnaissance Office from historic Launch Pad 39A at the Kennedy Space Center in Florida. Now, today's mission and final orbit are classified, and as such, we'll conclude coverage of the primary mission following separation of the fairing. But because we are going to be bringing back our first stage at Landing Zone 1, we will attempt to recover this at Landing Zone 1, and we'll continue to cover this secondary objective once the primary mission coverage has concluded. For today's mission, that landing will occur in daylight, and it should produce some incredible footage.
It does seem that maybe also...
Now, the Falcon-9 is vertical right now at Launch Complex 39A. This is the same launch pad that the Saturn V took off from for the Apollo program, as well as many space shuttle launches. In fact, you still see some of the structures surrounding the Falcon-9 rocket from the space shuttle days. We first leased that pad a few years ago, and since then, we've started launching from that pad at the beginning of this year. As you can see, the Falcon-9 launch vehicle is erect, vertical right now. It was rolled out of the hangar a few hours ago, and that vehicle stands over 200 feet tall. It's roughly 12 meters in diameter, about 36 feet. This Falcon-9 launch vehicle itself, it's a two-stage rocket. There's a first stage at the bottom, joined by an interstage, a composite interstage, followed by a second stage made of aluminum. And then on top is the payload fairing. That's where the payload for today's mission is encapsulated.
Possibly due to the classified nature, there is no technical webcast, so there's only the hosted webcast.
It's a bit like breathing out of your mouth in a cold winter day, and you see that puff of smoke coming off as the gaseous liquid oxygen. The liquid oxygen becomes gaseous. Now at liftoff, the thrust of that Falcon-9 is roughly equivalent to about 5 747s taking off. When all 9 of those Merlin engines fire, it's capable of putting out over 1.7 million pounds of thrust. Now, as I mentioned previously, we are going to be attempting to bring back our first stage at Landing Zone 1. And you'll see that pad on your screen in a few minutes. It is nearly 300 feet in diameter. It will look small from the far cameras, but Landing Zone 1 is a 300-foot diameter pad. And there you see it right there. We first successfully landed on that pad about 16 months ago when we delivered 11 Orbcomm satellites to low Earth orbit. Now, since that mission, we've had 2 other successful landings at Landing Zone 1, with the most recent occurring on February 19th of this year. And And as we mentioned previously, today's mission is classified, and as such, we're going to conclude coverage of the primary mission following separation of the fairing, but we will continue to cover the land landing attempt, our secondary objective for today's mission.
Engine bleed started.
Though actually they do manage to land pretty much in the center of the landing pad usually. The main reason the landing pad is much easier than the drone ship is actually in navigation and contact. That is, it's just when landing on the landing pad at Cape, the rocket has a easier time finding navigational equipment
We
to
have a little
actually.
over 6 minutes left in today's count. The good news right now is all systems are go for an on-time launch from Kennedy Space Center in Cape Canaveral, Florida. We are just inside a 6-minute mark, which means we are topping off RP1, or we just finished topping off RP1 on stage 1. We'll continue to load liquid oxygen onto the second stage until the T-3 minute mark. We try and load that as late as possible to keep that liquid oxygen as cold as possible as we do densify it before we load it onto the vehicle. Now, this entire fuel loading process is about 1.1 million pounds of propellant we're loading on over the course of a 70-minute process. We also have been given the go from the range for today's mission. Kennedy Space Center and Cape Canaveral Air Force Station are tracking no issues. And we are looking at no issues from weather to report. Now, this is a 2-hour launch window. If any issues do come up in today's count, we would have the opportunity to recycle and target a launch towards the end of the window. We also, if anything did come up, we do have a backup launch opportunity tomorrow at the same time. But for now, all systems continue to be go at Cape Canaveral and Kennedy Space Center.
Vehicle's pressing for strong back retract. Strong back lower sequence has started.
Now, in case you missed it, about a month ago, SpaceX added to the incredible history of Pad 39A with our launch of the SES-10 satellite to geostationary transfer orbit. Now, you're seeing that launch on your screen right now of the first time that, for the CRS-8 mission, where the booster of that rocket, the first stage, lifted off when we were delivering our 8th commercial resupply services mission to the International Space Station. We brought that booster back, performed a bunch of inspections, and we then launched it with the SES-10 satellite. That's the launch you're seeing right now on your screen, and successfully delivered the SES-10 to that geostationary transfer orbit, and again landed it back on Earth on our drone ship, Of Course I Still Love You. This launch and landing and relaunch marked the world's first reflight of an orbital-class rocket. And it was a very exciting day for all of us at SpaceX, and certainly everybody in the aerospace industry.
T-minus 3 minutes.
Now we're just 3 minutes left in today's count.
GNC verify stage 2 TVC motion nominal.
You heard about a minute ago the vehicle pressed up for strong back retract.
H2 TVC motion acknowledged.
The forward arms of the strong back opens and the strong back retracted back a degree and a half. Our liquid oxygen loading has completed on the stage 1. They performed the final TVC checks on the Merlin engines.
Complete. Strong back at 88.5 degrees.
And the strong back has fully retracted to its resting state before liftoff. That strongback will retract fully at the moment of liftoff. Coming up in the final, at the final minute, our flight computer is going to enter into its terminal count auto sequence start. That's where it's going to perform a series of hundreds of checks across the sensors on the vehicle and really set the vehicle up for its final few moments before liftoff. And with that, we're actually going to turn it over to terminal count unless you listen in to the final minute and a half of today's count.
Vehicles in self-line. And closeout started.
FTS, verify AFTS is ready for launch.
AFTS is ready for launch.
Ground side gas closeout's complete.
Hold, hold, hold. This is launch director calling a hold on the countdown bed. We have an issue with the Toto sensor on first stage. Launch conductor, please put us into a 24-hour recycle.
Copy. Launch abort is running. BD when prompted, please proceed with script side saving.
Yep.
ECGC standby on FireX.
And LC starting scrub side saving.
Now, if you're just tuning in right now, or if you've been watching along, you did see that the launch conductor did call a hold for today's mission. The team was looking into a sensor issue on the first stage that was a bit out of family of what we were expecting. And out of an abundance of caution, we have decided to scrub today's launch. We do have a backup launch opportunity tomorrow, same time, 7 a.m. Eastern time. The window will open. So with that, that will conclude our coverage today. Due to a sensor issue on our first stage, we are going to scrub today's launch and pick it up tomorrow for our backup opportunity, same time. So for further updates, please follow along with us, Facebook, Twitter, Instagram, as well as our website, SpaceX.com. We'll keep you updated on our progress as we lead up to our second attempt for tomorrow's launch. Thank you again for joining us, and so long for now.
Okay, this was a pretty close and pretty quick scrub, so kind of anticlimactic. I'll try to mirror it again tomorrow, then probably also less tired. I am a bit surprised that they didn't try to figure something out over the 2 hours and then scrub it for tomorrow at the end of the 2 hours, but it's hard to find any actual in-depth details since the mission is pretty much classified. Yes, next mirror for tomorrow will be roughly the same time, maybe a few minutes later, though I will first have to check the exact launch window for tomorrow, since depending on the exact target of the satellite, the launch window may shift for around a few minutes with the launch opportunities. Unfortunately, the exact type of sensor problem is not yet open to public. I hope I'll have more information by tomorrow when the second launch attempt will be done, and then it will probably succeed, because if it is again halted tomorrow, it will probably be reattempted within the 2-hour launch window. Then on May the 4th, an Ariane 5 will launch from Kourou, which I will also mirror, and that should be about it for live mirroring for this week. Unfortunately, I cannot give you a hint either, since I don't know it myself. While I do follow SpaceX rather closely, I'm not actually involved in the SpaceX launch operation, so I can not. I don't know anything they don't publish, and by now they haven't published anything more exact than it being a sensor issue. Since it's been a very little while, like a few minutes now, since the scrub, and they haven't published any more exact information on the type of sensor issue yet, I'm pretty sure it won't come out until almost tomorrow, like a few hours before the next launch attempt probably. So this will be it for today, and I'll be back tomorrow.